Namaskar and welcome back to another lecture in this series on concrete engineering and technology. We will continue our discussion on special concretes. In the last few classes, we had covered high flowability and self-compacting concretes, and we had talked about how the properties of the paste phase or the mortar phase need to be engineered in terms of viscosity and so on, so that the concrete has adequate flowability as well as segregation resistance. Then we had examined some of the common test methods that can be used to evaluate the properties of these special concretes in terms of their flowability, passability, self-compactability and so on. These tests were over and above the normal test that we use. In fact, the rider was that in special concretes, we basically need special tests in order to evaluate them and determine their suitability in terms of use, and at the same time these special tests should be really a part of the quality control regime that we make when we are using these special concretes. Now, one of the considerations in that discussion that we did not mention specifically was sloshing. Now, this is a phenomenon which occurs when fluids are being transported in trucks. Now, in the case of high flowability concretes, the concrete is more or less a fluid, and while it is being transported in agitator trucks, we have to be careful that the concrete does not slosh, and if it sloshes, what are the implications of that? So, the driver who is transporting these concretes in his trucks needs to be aware that the concrete he is transporting or she is transporting is not really normal concrete and has a tendency to slosh. Now, that really shows that once we are using special concretes, there is a need to not only do quality control and so on as far as the material is concerned, but also adequately train the personnel who handle these concretes. Continuing from that discussion, I would like to also emphasize the need for validation and verification of laboratory tests in the field. When we are talking of special concretes, we may carry out certain tests in the laboratory, but it is important that all those tests are verified and the results seem to be matching in the field, because there can be all kinds of reasons why the mixing conditions, the batching conditions and so on may be different in the field than those that were available or that were practiced in the lab. So, there is a reason why we must ensure or insist that the properties of the concrete achieved in the lab are duplicated or they are verified in the field tests. We should remember that cement is the only factory made product that we use as far as the constituents of concrete is concerned. As a result of that, we can expect, and indeed we get, a lot of variation in the properties of the ingredients and therefore the properties of the concrete. We had alluded to this when we were talking of high flowability concretes in terms of the properties of the coarse aggregate, their size, the particle size distribution, the surface characteristics and so on. All that changes from lot to lot, from quarry to quarry, and therefore, we need to have methods which are robust enough to take care of these variations. So, concrete, even though ready mix concrete, even though it is a factory made product, it is susceptible to a much larger variation than that we can expect from another factory made product, and that is something which we need to be very, very careful about when we are talking of special concretes. We have the issue of compatibility of materials, especially in terms of cements and chemical admixtures. The cements, even though they are factory made, it is always likely, it is always possible that there may be a slight variation in the quality in terms of their chemical composition and so on. So, from the normal tests that were carried out, which were very superficial in a manner of speaking, those differences would not even come out. In fact, in sites we hardly ever carry out a chemical analysis, for example, of cement. What we do is fineness, initial setting time, final setting time, strength development, and so on. When we are talking of special concretes and we are using chemical admixtures which have the tendency or which can cause changes in the properties of concrete in minute doses, then these tests need to be verified. We have to be very careful to ensure that the mix that we use is robust. The properties that we get are within an acceptable range. Continuing with the discussion on variations, mineral admixtures like fly ash or blast furnace slag could also vary in property. For example, fly ash, the properties would vary depending on the kind of coal that is used in the thermal power plant. It would vary depending on the temperature that the furnace used to fire the coal, the method of collection of the fly ash, and so on and so forth. So, in a nutshell, concrete is not a material which can be easily duplicated. That gives us a sense of uniqueness of each concrete mix, and that uniqueness is something which we must understand. And no matter how much experience we get, we must always ensure and insist that the properties that we obtain in the lab are replicated at site using the site conditions. Now, this was a general discussion, a few general remarks on handling of special concretes, and continuing our discussion as far as special concretes is concerned, we will concentrate or focus on two aspects today. One is concreting underwater. Very often we need to place concrete underwater. It is just not possible to remove all the water and then try to create a dry environment for concrete. We sometimes need to place concrete underwater or in water, and there we need special considerations. We have to be especially careful, and that is what we will talk about today. And we will talk about shotcrete. This is another special method of concrete construction. So, underwater concreting and shotcrete is what is the topic of today. Continuing with our discussion, underwater concreting, there are certain keywords that we need to keep in mind. One is still versus running water. So, one situation can be when the concrete is being placed in still water, that is, the water is not running, there is no movement in the water and concrete is being placed there. So, all that concrete has to do really is to displace the water and be there, whereas in running water the concrete can be swept away, it can segregate a lot more easily. Of course, even in still water the tendency to segregate will still be there, but in running water it becomes even more, which means that when we are talking of concreting underwater or placing concrete underwater, one has to understand the implications of still versus running water and lay down a specification that if the speed of water or the velocity of water is more than a certain number, then certain other provisions will apply, certain other specifications will apply. The same concrete which can be placed in still water may not meet the requirements when it comes to running water, and so on. So, once the engineer is aware of the fact, then he is looking for the right kind of specification as to what is the kind of concrete that is going to be used under those conditions. Another keyword that comes to our mind when we are placing concrete in water is self compactability and segregation resistance. Concrete falling through water has a much larger tendency to segregate. It should also be such that it should be self compactable. We do not want to vibrate concrete underwater. We would like to just place it, let the concrete take the shape of the form which has been set in place and harden. So, we would like the concrete to have self compactability it should be able to move through the reinforcement, because of course, as far as underwater concreting is concerned, it is not really plain concrete all the time. There can be a reasonable amount of reinforcement in those structures, and the concrete can be reinforced concrete, and therefore, the concrete should be able to negotiate the spaces between the reinforcement and should have adequate segregation resistance. As far as the methods of construction is concerned, one of the methods that is commonly used is tremies or buckets and so on. So, in any case, the concrete is simply taken in underwater and dropped. We will talk about tremie construction a little bit later. We have to be careful whether the concrete remains always submerged. Now, if it remains always submerged, the kind of demand on the concrete is different compared to a situation where the concrete may be placed underwater, but over a period of time during its service life, it is exposed to air at times. For example, if it remains underwater all the time, then considerations like drying shrinkage simply do not apply. Whereas, if it is exposed to the atmosphere or the air during certain periods of its service life, then we have to be careful in terms of drying shrinkage and the related issues in concrete. We can talk in terms of underwater concreting in two ways. One is that we have a special method of construction which enables us to do the construction underwater, but the concrete that we use is normal concrete or slightly modified concrete. That is, sometimes it is stated in codes and procedures that if the concrete is being placed underwater, a certain amount of extra cement may be used or should be used. That comes from the fact that the code writer believes that when the concrete is being placed in water, a certain amount of cement may be washed away, and therefore, as long as we are putting an extra amount of cement in the system, strength development and so on will not be adversely affected. The second approach is to say that, well, we design a special anti-washout concrete which does not segregate when placed in water, and this is something which we will see in a couple of slides later on. Let me just spend a minute on tremie construction or the construction using buckets. What is really done is that if we have this as the let me spend a minute on how construction underwater is effectively done. We have water from here to, let us say, this point. So, this is all water. This is the formwork that we have put in place, and we want the concrete to be placed within the formwork without having to remove or without being able to remove the water. So, what we do is lower a pipe which is called the tremie pipe. We put concrete into this, and as the concrete emerges here, we gradually raise this pipe, keeping on pouring more and more concrete into it, making sure that the fresh concrete that emerges here is not in contact with the water, and only the initial concrete which came out or emerged from the tremie pipe is in contact with water. As the tremie pipe moves up, more and more concrete gets poured all over the place, and we are able to get a construction underwater. Depending on the size of this member that we are trying to cast, 2 pipes or more than 2 pipes can also be lowered, and it should be ensured that the concrete has been placed in a manner that there are no cold joints and so on and so forth. So, as far as tremie construction is concerned, one of the important precautions that one must maintain is that the end of the tremie pipe is always submerged or always buried in the concrete and is not exposed to water. What we do not want as far as tremie construction is concerned is that the tremie pipe allows the concrete to fall underwater, and this concrete is always, fresh concrete is always in contact with water. So, if the concrete is allowed to fall freely in water, that is something which is not acceptable as far as most TREMI construction is concerned. We try to avoid free fall in air, more so in water. So, as far as water is concerned, we must insist that the TREMI pipe is always buried in concrete being placed. Now, coming to the areas in which we are looking for such concretes, it could be in terms of bonding and solidifying rocks and or concrete blocks in shore protection works and marine structures, or it could be in underwater reinforced concrete used in structures such as wharves, intake and discharge facilities for industrial plants. So, it is not all the time that we are talking in terms of marine structures. It could be industrial plants, it could be rivers, anywhere. It could be an alternative to precast construction in breakwaters. It could be foundation work in any bridge. It could be in terms of maintenance work of any of these underwater structures. Now, if we look at anti-washout concrete, that is the special concrete or a special concrete which has properties that enable it to be specially useful underwater. This picture here shows an anti-washout mortar, that is, we do not have aggregate in it, but if we look at a normal mortar which has been placed or which has been dropped in still water, then we see so much of muddying of the water, and that is really the washout that is occurring as far as the cement and the fines are concerned. It is not only the cement which is being washed out, it is also the fines in the mortar that are washed out, and the water becomes muddy, but it, of course, particles being heavier than water, there is a certain amount of settlement that occurs as well. Now, if we are able to have a concrete or a mortar which is something like this, that it can be dropped through the water without muddying it, then we have the basis of an anti-washout concrete or an anti-washout mortar. That is, we have imparted to the mortar sufficient amount of cohesiveness that the washout or the tendency to wash out is overpowered by the cohesion. Now, the point really is, how do we impart this cohesiveness, and that is what is the crux of the problem as far as design of anti-washout concretes is concerned. Another thing that needs to be reiterated here is the fact that so long as we have a mortar which is anti-washout, getting to a concrete which is anti-washout is not all that difficult, because at the end of it, aggregate suspended in mortar is the concrete. So long as the mortar does not have a tendency to segregate, it will keep the aggregate with it, and therefore, we will get an anti-washout concrete. Another picture here shows that of placing underwater concrete using a diver. So, here we are not really using a TREMI kind of construction. Here the diver is simply placing the concrete just as a normal material being placed underwater. So, one of the things that is notable about this picture is the fact that you can see fish around here, which shows that the concrete is not segregating, or there is very little washout that is occurring in the concrete. That is, there is no muddying or sullying of the water around the place where it is being placed. So, this is the kind of construction that we are really talking about. This is one of the very famous photographs of underwater concreting, and I would encourage you to take a look at it sometimes and try to study about it a little more. This again is another picture of a rehabilitation kind of work, where a diver is trying to place high quality underwater concrete without disturbing the marine life. Anti-washout concrete is something which can be placed underwater in a manner which is as easy and similar to that of normal concrete being placed in air. When we are placing concrete in air, we do not think twice. Similarly, when we are placing anti-washout, similarly when we are trying to place anti-washout concrete in water, we do not have to think twice about its segregation and so on. initial development as far as anti-washout concretes is concerned took place in Germany, and it was followed by extensive research and applications in Japan. And the concrete uses a viscosity agent as an additive to normal concrete to address the problem of segregation and bleeding underwater. So, this is what is the crux of anti-washout concretes. As far as the materials are concerned, normal blended cements can be used. As far as admixtures are concerned, one has to be careful. It is primarily the trick involves the use of cellulose ether based viscosity agents, which provide the erosion resistance to the concrete. And of course, we need to have superplasticizers to reduce the water demand. As far as the dosage of these admixtures is concerned, some experiments have to be carried out to determine the right kind of dosage. Normally speaking, as the dosage of a chemical admixture is increased, its effectiveness increases, but at the end of it there is a limit beyond which further addition of the admixture does not lead to any improvement in the desired property. So, what we are looking at is a curve which is something like this. That is, at this point, if the dosage is very low, the effectiveness is pretty low, but within this range, as we increase the dosage, if this is the dosage and this is the parameter that we are trying to monitor, then in this range it makes a lot of difference as to what is the kind of dosage which is being used. But beyond this point, there is no real point in increasing the dosage of the chemical admixture. Obviously, has the implications in terms of the money. That is, the concrete becomes more expensive. So, we must know this point, because we should understand that beyond that point there is no effect of or no improvement that we get in terms of the property of the concrete. So, as far as the viscosity agent is concerned or the superplasticizer is concerned, we have to be careful and try to determine these points, the effectiveness, and that is what varies from one admixture to another, one cement to another, and compatibility issues come in. So, that is why we need to have a online kind of a laboratory, which is a very real time laboratory, which keeps testing the cements that are coming in and being used at sites, and also the chemical admixtures when it comes to these special concretes. Now, as far as the consistency of anti-washout concrete is concerned, it is governed by the placing method and the placing condition. So, with this we conclude our discussion on anti-washout concretes. So, in a manner of speaking, anti-washout concrete is basically just another high flowability concrete, which is especially designed to be placed in water. Now, from this regime where we are talking in terms of slump flows and so on, let us move to another concrete, which is shotcrete, and this is an entirely different method of concrete construction. And as far as the definition is concerned, it is a concrete that is delivered to the final point of placing in a sealed pressure resistance hose or pipe and applied by spraying. This concrete requires no formwork and self compacts. Now, if we look at this picture, which shows shotcrete construction in progress, this here is the area or the place where the concrete finally needs to be placed, and it is being transported through this pipe, which is under pressure, and the concrete is being pumped out under pressure, coming out through this nozzle and is getting deposited on the surface which is being concreted. So, in a manner of speaking, if this is the surface on which we want to concrete, we take a nozzle here, bring concrete under pressure, and this concrete is deposited on this surface. So, this is what is the fundamental shotcrete construction. Now, in order to have this construction, what are the kind of things that we need to do as far as the concrete is concerned? This is something which is very different from normal concrete construction in terms of formworks, in terms of vibration and all that. As far as formwork is concerned, of course, as we can see here, there is no formwork requirement. The concrete is applied on a surface and simply stays there. In very special cases, concrete could be deposited against a formwork which is then removed. but that often does not happen. As far as compaction is concerned, in the case of shotcrete, it is achieved by the high speed of deposition. So, when concrete particles, whether it is cement or its coarse aggregate and so on, the fact that they are deposited with a certain amount of speed, that ensures that the concrete compacts, or it compacts the layers of concrete being cast. So, if we keep this picture of shotcrete construction in mind, we will understand the kind of discussion that follows. The applications as far as shotcreting, or sometimes also called gunniting, could include constructions in bridges, repair works in bridges or dams. As far as seawalls are concerned, whether it is sanitary or storm or culvert basins, head walls, wing walls, piers and docks, ditches, retaining walls, slope stabilization and so on. So, there are lots of areas in civil engineering where shotcrete finds an application. It is not only structural engineering in terms of buildings and so on that it is required, it is also required in terms of stabilizations of soils, it required in terms of stabilization in slopes, it is required in repair work of structures and so on. Now, the properties of the shotcrete as placed depend on not only the material and proportions etc., but also the skill of the nozzle man, that is the person who is operating the nozzle. So, this is similar to that of a diver. The role that a nozzle man plays as far as shotcrete is concerned is similar to that of the diver as far as underwater concreting is concerned, as we saw in the previous discussion. So, the workmanship is of critical importance in a quality control plan in shotcrete construction. In principle, there are two methods of placing shotcrete. One is the dry mix process and the other is the wet mix process. And what these processes are is almost self-explanatory. For example, if it is a dry mix process, what we have is cement, moist sand and coarse aggregate, which may or may not be there. In certain cases, we use simply mortar. That is brought into a delivery equipment, into a delivery hose, we compress it, take it to the nozzle, and at the nozzle we add water under pressure. So, there is no real mixing of the dry material with the water prior to coming in contact at the nozzle at the very end, and then the concrete is sprayed onto the surface. So, the pre-mixed blend of dry cement and aggregate is propelled through a hose by compressed air to a nozzle, and water is added to the mixture at the nozzle, and the mixed ingredients are projected onto the application surface. Now, the fact that no initial mixing is being done with water makes this concrete procedure or this process the dry mix process of placing shotcrete. In contrast to this, the wet mix process involves shotcrete in which all ingredients except the accelerator. Now, that accelerator is a chemical admixture. So, all the ingredients of concrete other than the accelerator are mixed before introduction to the delivery hose, and only an accelerator, if required, is added at the nozzle in a manner that the quality can be appropriately regulated and monitored. So, we have all the ingredients of concrete in the initial stages itself. Concrete has been mixed in a normal manner and is finally being taken to the nozzle and sprayed onto the surface where it is going to be applied or where it needs to be applied. Now, a word about the role of this accelerator. In a normal concrete, when it is being placed against formwork, we are in no real hurry that the concrete should harden, except that yes, we want that the concrete should harden as soon as possible after it has been placed, so that other activities can follow. But in the case of shotcrete, where the concrete can be placed against a surface like this, which means that we want to deposit a layer of concrete like this, or for that matter, if we are talking of a tunnel where we are trying to deposit the concrete in this form in a layer like this, we have the problem of concrete being simply falling off if it is left to harden for a long time. So, in the case of shotcrete, the fact that it is not being cast against formwork, the fact that it is not supported in the initial stages by formwork while it hardens, makes it important that once it is placed, it hardens very quickly to reduce what is rebound. Now, this falling off of the concrete can be called rebound or simply a separation and so on. And in order to minimize that, what we need is that the concrete, once it is placed in position, should harden very quickly, and that is why we need an accelerator. Now, we cannot use an accelerator in this stage here, because we do not want the concrete to harden while it is in the system here. We want the concrete to harden only after it has left the nozzle and it has been deposited. Now, continuing with our discussion as far as shotcrete is concerned, given the method of placing, shotcrete ingredients can also be pre-bagged, though all the ingredients can be batched and mixed at site in the usual manner. Depending on whether we are using the dry process or the wet process, we can use pre-bagged materials, which takes away any kind of variations that are likely to happen when we are talking in terms of mixed proportions or batching of different ingredients. To some extent, it gives us better quality control in terms of the choice of the ingredients and so on. But if we do not want to do that, we can actually use normal concreting process and mix the concrete in a usual manner, except that the method of placing is not normal and we are trying to spray the concrete onto a surface. Now, given the nature of this construction, fiber reinforced concrete emerges as an excellent option. So, we will find in literature that very often we talk in terms of, or we find applications of fiber reinforced shotcrete. Why fiber reinforced shotcrete gives us excellent options, we will talk about in a minute. As far as fiber reinforced shotcrete is concerned, we could use steel synthetic fibers dispersed homogeneously in shotcrete. It imparts sufficient ductility, and fiber reinforced shotcretes have become cost competitive with other forms of reinforcement, and they impart better safety and easy to use benefits than traditional reinforcement. Now, only in certain cases this discussion is true, because fiber reinforced concrete most of the time cannot really replace normal reinforced concrete. Fiber reinforced concrete, as we have talked earlier, really just alters the properties of the concrete, makes it more crack resistant, makes it more difficult for cracks to propagate through the concrete. The normal process of reinforcement is quite a different mechanism. But as far as shotcrete is concerned, where concrete is actually deposited in layers, there fiber reinforcement is of great help, because it prevents any kind of crack formation in those layers. Well, not really prevents in the absolute sense, but minimizes. Now, these are some examples of shotcrete applications. This application here is that of a deteriorated corrugated steel pipe. So, we can see that its rehabilitation will require a lot of effort, and if we look at this picture here, we find that the shotcrete has been placed on the surface of the deteriorated corrugated iron sheet, and we get a reasonably clean looking system. Coming to a brick sewer, if we look at this brick sewer here, we find that it is highly deteriorated, and once we are able to apply shotcrete on the surface here, we get a system which is rehabilitated or which is repaired. So, what we do is apply shotcrete on the surface of this sewer here, including the top and so on, and we get a refined or a different surface of the concrete or a different surface of the sewer. This here are pictures of a rehabilitation of a in the infrastructure projects in terms of bridges, in terms of marine structures, in terms of seismic retrofitting. One must remember that concrete structures, though they are easy to build, they are not so easy to demolish, and there is always a temptation to extend their service life, and that temptation to increase their service life or keep extending their service life leads us to solutions such as application of shotcrete and so on. So, if we have an existing concrete structure, we want to increase its cross section, we do not want to demolish the structure and build a new structure, the option is shotcrete, because at the end of it what we want is just to increase the thickness, and to increase that thickness and try to place concrete in a normal manner sometimes is not possible, because of the fact that then concrete requires to be flown in very narrow spaces, and that may be not possible except for using self compacting concrete and so on. So, a choice often emerges in terms of whether using formwork and self compacting concrete or using shotcrete. This is another of those rehabilitation case studies where we have a retaining wall being repaired using shotcrete. Now, if we look at this picture closely, we will find that shotcrete surface or a shotcreted surface is not necessarily a very plain or a very smooth surface, and it will be that because the method of placement is such that the thickness of concrete deposit may vary depending on the skill of the nozzle man, and that is what causes variations in the thickness of the concrete deposited. In certain cases where this thickness is of critical importance and we really want to measure that thickness as a part of quality control, we need to have methods by which the thickness of this deposited shotcrete is properly determined and recorded, so that we know that what we had set out to achieve is what we have achieved. This again is a picture of a retaining wall with rehabilitation. Here we can also see the application of a reinforcement net and also nails to anchor the shotcrete to the existing retaining wall. Now, coming to the characteristics of the shotcrete, very often the material is characterized with a low water to cement ratio, especially in the dry process, and that has its advantages in terms of strength development and so on. Because of the fact that we use accelerators, we also have high early strength in the case of shotcrete. We also have a lot of wastage of the material by way of rebound after placement. So, a certain amount of rebound is unavoidable when we are talking of shotcrete construction, and that is something which an engineer must account for. With the skill of the nozzle man, the rebound can be minimized, but it cannot be eliminated. As I said before, the compaction in this kind of construction is on account of application of concrete with high speeds. We might sometimes have reduced cost in shotcrete construction, as we do not have any expenditures to make on formworks. Shotcrete construction is ideally suited for thin layers. It cannot be placed, or shotcrete cannot be placed in thick layers, at least in a single go. So, what we can do is to have one layer of shotcrete and then another layer of shotcrete, but it is difficult to have this whole thickness being shotcreted in one go. As far as curing of shotcrete is concerned, it is the usual process. The concrete needs to be cured continuously by maintaining a moist condition, which could be by way of ponding or continuous sprinkling of water, covering with a mat which is kept wet, covering the concrete with an impervious sheet, or use of curing compounds. Of course, if the relative humidity in the atmosphere is higher than 95% or something, then of course requirements for external curing may be reviewed, because at the end of it, curing is a process by which we try to eliminate or minimize any loss of moisture from the surface of the concrete, and we want to provide as much water as we can for the hydration and strength development of the material. So, the basic understanding of cement concrete does not alter when we are doing shotcrete kind of construction. As far as materials and properties are concerned, I have already stated that concrete construction is economical only to the extent when no special materials are used, and therefore, even in this case no special materials as such except that care has to be taken in choosing the cement, coarse aggregate in terms of its shape and size, chemical admixtures from the point of view of compatibility, and fibers if added. We have to be careful in the choice of the materials and ensure that we do not have a problem in terms of rebound, in terms of carriage, in terms of the distance through which the concrete has to go in air before being deposited, and quality control has to be carried out as usual on the basis of compressive, tensile and flexural strength or any other relevant parameter depending upon the specific application. Now, having gotten this overview of shotcrete, let us try to close the discussion today with a series of questions. We could make a list of case studies where special concretes have been used in underwater construction. So, what we are talking about is the application of anti-washout concretes, as we have seen in the first part of the discussion. We can make a list of the proportions that have been used in these cases from the point of view of the use of chemical admixtures, especially viscosity modifiers in terms of their chemical nature or the chemistry of the viscosity modifiers, how it acts on the cement hydration, and its compatibility and dosage with different levels of strength. Coming to shotcrete, one could compare the specifications from the point of view of sampling and testing procedure. One thing which we have not covered specifically here, and I would like to leave it as an assignment, is the sampling process. In the case of underwater concrete, for example, how should the cubes or cylinders be cast? The concrete is normally brought to site in an agitator truck, and would we like to take the cubes or cylinders for monitoring the strength development in air in the normal manner, or we should do it underwater with the help of the diver? That is something which needs to be decided by the engineer. We could do both, and that is something which you can decide or you can think about. If you were the site engineer where underwater concreting is being carried out, what is the kind of regime that you would like to follow? What are the specifications? What do the standards say? Because at the end of it, it cannot be left only to the whims and fancies of the project manager. Similarly, in the case of shotcrete, how should the sampling be carried out? Because when we are shotcreting, it is simply not possible to actually take the or cast the cylinders or cubes. So, what usually is done is that a panel is cast other than the kind of normal casting, and cores are taken out of the panel and tested for strength. These are some of the things that maybe those of you who are more interested could do some reading on and educate yourself. Thank you.